Hey everybody, today we're going to give an overview of neural nets and start using the terminology that will be used in Keras and TensorFlow. And so I'll give the anatomy of neural net and neurons, and then we'll start doing some programming. And you can use this lecture as a review of Python as well. So we'll implement some code and use the same terms that are used in the Keras module so that you get a head start on that, and it'll be easy transition into developing more complex models. So use this as a review, and then I'll start talking about some of the terms that were often used in machine learning. So to start out with, let me give you an overview of kind of the anatomy of a neural net. So this is the input layer, and then this is often called the hidden layer. And this input layer is really a sample, and each one of these circles here can be thought of as a feature. And each of those features are being forwarded to a neuron in the hidden layer. And the details about the neuron are here is that ultimately what we're doing with a neural network or machine learning algorithm is we're going to be optimizing the weights for each of the input values to a neuron. And so these lines represent an input and often referred to as the x's in your model. And then what we will do, we'll feed forward through the network and then use a cost function to optimize the weights. And that's the whole objective of machine learning, is to optimize these weights as well as the bias. So neuron has inputs, x values, and then we're going to be optimizing the weights and the bias for each of the neurons. In a few lectures or a lecture in the future, we will talk about activation. And so activation is just a term that you should be aware of, is that there are different activation functions that add nonlinearity if you use multiple layers within the model, and also help scale the data so that we can solve the problem. So we'll talk about activations in the future. So this whole thing is one neuron, and then if we put those together into a machine learning model, we have input layers, and then here's a layer of neurons, first hidden layer, and we can have multiple hidden layers, and then finally we have the output layer, which is the result of my model. And you can have many of these outputs. So if you had 10 elements, you'd have 10 output neurons or outputs, or you could have one, or a binary classification, 1 or 2. So depending on the type of architecture and the type of model you're creating, you could have a different output as well. So I've constructed a very simple example to kind of conceptually talk about this even further, is if we had the skyline of Austin and Dallas and we wanted to make a classification algorithm, and we could feed into our algorithm some features, and a feature in this case is going to be the height of the building. So I've got, this is a 5, so that's the tallest one, 4.2, 2.3, and 1.0. You can see that there's a slight difference in the features. Now we could have more features. Dallas has more buildings, so we could have more features here, but I've only picked 4 to begin with. So one of the challenges of machine learning is to get enough data, so that samples, so that we can create an accurate model. And right now we just have one feature or one sample of each. This really doesn't make our model very robust, meaning that it could work over a large sample size. Now you could think about the inputs. We could have, let's say, the skyline from a different direction. How would that impact this? So ultimately, you want to create an algorithm that would be very robust and work over a lot of different versions of this. And we'll talk about that in the future. There's techniques to be able to create more data, augment the data, so you can make your algorithm much more robust. So let's go ahead and do some coding so that you can kind of review Python if you haven't been in Python for a while, and I'll use some of the same terms that'll be used in Keras. So I encourage you to code along with me, and you can slow down or speed up the video. I usually talk pretty fast. I've had a lot of coffee this morning, so I'm going pretty good. So I'm going to go through this pretty quickly, but you can slow it down or stop it and do the coding yourself. I've kind of preloaded my sample, my one sample, called it x, just like we did above here, right? So this is my x values. And what I'm going to do is take 5, 4.2, 3.3, 1.0, I put that into my sample list here, so that's a single sample. And then let's add a random bias. And when your neural network is initialized in the beginning, the biases and the weights are randomized. So let's just put in some value, 0.2 for the bias, and the weights for a single neuron. So really what I want to do here is add weights 1, weights 2, weights 3, and I have 4 features. So I need to have 4 weights to go along with that. So here's my four features. And so let's just call this, let's use weight 1 as kind of our first example here. And I'm going to do something real simple. I'm going to copy this, and put that in here, and then we'll just make these different. And we're going to keep this real simple. This is not about accuracy of the model, it's about kind of reviewing programming and reviewing the nomenclature for models. And so I'm going to make that real simple. It's called weight 1 is 1, 2, 3, 4. Okay, so those are going to be the initial values, randomized values that we input to our weights. Now if we were to create the output from a single neuron, so I'm not coding these two right here, I'm just coding this single neuron, this first one. So I need to multiply the weights times my input values and then get output. I'm going to ignore the activation for now. We'll add the bias though. Okay, so let's go ahead and do that. So if we were to say output equal capital X, we need to get the first element. I'm going to do element by element multiplication, and then weight 1, and so forth. Now we can code this up pretty quickly. We'll just take that and we'll copy it, and then change the variable names. And then finally we have a bias, which is a single bias that we've added. So weight X element 0, weight 1 element 0. Now this needs to be 1, 1, 2, 2, 3, 3, and bias. So let's go ahead and print that output to see if we got any errors in our code, and then we'll do a little troubleshooting if we have some errors. So let's clean that up. Output 28.7. Okay, let's see that. We'll kind of do a test here. So that's 5, 8. Yeah, that looks about right. So that looks good. All right, let's do a little bit more coding here and talk a little bit more about the language of neural nets. I want to expand from 1 neuron to 3 neurons. And I have 4 inputs to each of those neurons. So how are we going to do that? Let's just extend our current model with the weights for now. And we're going to do it this way. So weights 1, weights 2, weights 3, and then each of those will have 4 inputs. Okay. So we've got 3 neurons above, right? So 3 neurons, we have 3 sets of weights, but each of them will have 4 inputs that we're working on, 4 of the features. So there's the weights, 1, 2, 3, 4, 1, 2, 3, 4. Let's change this to 2 and 3. And now what we're going to do is we're going to multiply and create an output corresponding to 3 neurons with 4 inputs. So let's do that real quick. 3 neurons with 1 sample with 4 input features is what we're doing, right? Let's go ahead and basically do this. Let's call this outputs, and let's put this into a list. And then what we're going to do is also create the biases. So I'm going to go down here because we just have 1 bias above. We need 3 biases, and let's go ahead and call that biases. And then we're going to do 0, 1, 2 as our biases. And so I'm kind of jumping around here, but I made a list, and then what I want to do now is make sure that my list corresponds to these weights 1, 2, and 3. So that's my first output from my first neuron, right? And this needs to be biases 0, right? And then now what I want to do is to have my second row, and these are the same features from the same sample, same input. So X's all stay the same, but the weights change to weight 2, weight 3, and weight 2. We're going to repeat that. So this is the second neuron. So that's weights 2, and so let's go ahead and do the third neuron, and we'll do that as well. So I think I've got everything right. I need to change my biases, so it's for each of the neurons. I need to do a little syntax checking here. So this is a list of lists, is the outputs that we've just created. And we need to have the biases first before we use them in our program, so let's do it that way. And then now let's print output, and then now this is outputs. Now you should be able to predict what I'm going to have as outputs, right? What is the shape of this particular output's going to be? Let's check that out. The shape is, it's really a one-dimensional array with 3 values for each of the outputs for the neuron. So this will be the output here for neuron 1, output here for neuron 2, output here for neuron 3. Okay, so now to further review our our Python coding here, let's get a little bit more sophisticated and do a little bit of array manipulation, and this will make the accounting for all of the weights and x's. And really, I think the complexity of neural nets is in the accounting for all the weights and variables. So let's see if we can simplify that a little bit further. And so what I want to do now is I want to just create a new variable called weights, and this is going to be a matrix. And it's going to be initially a list of lists. And then what I want to do is I want to take these same values here, so it's going to be two-dimensional, and I'm going to put them in this guy like this. So now we've got a weights list of lists, which is a 2D array, okay? Kept it all simple. We're not going for accuracy here, we're going for concepts, okay? Output array for, that's really my little code here, my little outline. Let's change that because that's what I'm doing here. Output array for 3 neurons and 4 inputs. Okay, that's what we just did there. And now what we want to do is create the weights. Let's organize code a little bit here. So this is what I'm doing now. Weights and list of 2D array form. And then now we need to make sure that biases, that we use this biases up here as well. So let's just copy that down to keep everything in order. And now what I want to do is use some numpy array manipulation. And I did not import numpy, so let's do that right here so that you are using the numerical Python library. And if you've used Python in the past, you should be up to speed on what numpy is. So we're going to import numpy as np. And now what I would like to do is I would like to say outputs is equal to the dot product. And that's really what we're doing. A dot product is an element by element multiplication. And we're going to take our inputs, or x's, times np as array weights. Let's see if that works. Plus biases. Yes. Plus biases. So this is a faster way to do this. So a couple things here to point out. Let's go ahead and run this, and let's print outputs. Print. And then let's make sure we know that this is different. So this is a dot product outputs. And then we're going to use the same variable name of outputs. Okay, so we should have 3 outputs now. And I have a little bit of let's see, I have some error checking I need to do here. It's telling me that the shapes are not aligned. Oh, and you know what? This is the biggest problem that you have in Keras, is that the shapes are not aligned. So, maybe this was the whole purpose of this coding, is that we need to make sure that the first argument of the dot product really defines the shape of the outputs. And so right now, the shape of this thing is X. And so we don't have 4 outputs, because that's how the dot product is created. So we need to have the weights first, and the weights basically determine. And so if we're doing a matrix multiply and a dot product, it's the rows times the columns, right? So I've got the first row, and then I want to take that times the column data of my inputs. Okay, so the column data for the inputs, well, we only got 1 row here for the inputs. So really what we need to do is we need to have X here, and then we need to transpose the weights so that the rows and columns align. And so I had to create an array here and do that in numpy so that I could use the transpose function, which is .t here. So let's go ahead and run that. So this is one of the biggest errors that you get in Keras, is that the shapes are incorrect on your nodes. And what I did is I just did a quick troubleshoot, is that I had 4 features, and I knew that I needed to do a dot product, and I needed to make sure that this was in a, since this is only a vector, there's 4 elements, so this is the rows, and then this should be multiplied by the columns. But my weights are not in column form. I had 1, 2, 3, 4, so I transposed it. So if we do real quick here, the transpose, show the output of this guy, it shows now we've transposed it, and now my rows and vectors are aligned. and we can then perform the dot product. Okay, so that's a very quick introduction to the anatomy of a neural network, anatomy of a neuron, idea of what features and samples are, a little bit of coding in Python. One of the top errors that you get in Keras is that the shapes of your tensors and your matrices are not aligned, and this kind of gives you an introduction of how to troubleshoot that. So I'm going to stop here, and we can talk during lecture or office hours about your results. Talk to you soon.